just see what is a real number and what is an integer number, right? So when we take an integer number, no, real number, it will be having a fractional part. So it is like 3.6, right? Real numbers will have fractional part, and the nearest integer to which we can just round off. 3.6 can be either round off to 4 or to 3, right? So this will be like 4 will be taken as an integer which is greater than 3.6, and 3 will be an integer which is lesser than 3.6, right? So now floor and ceiling is nothing but these are the just rounding off to an integer. Real number will be rounded off to integer, but the definition will be like a little confusing, that's all. So when we find the rounding off to a higher integer, it will be just ceiling, and when we are rounding off to a lower integer, it will be the floor. So I'll explain with the definition line. So in order to understand that definition line, I'm just showing it off. So here 3.6, when we find the integers which are greater than 3.6, which are the integers? 3.6 is a real number, right? It is having fractional part. So which are the integers which are greater than 3.6? So you may tell 4, 5, 6, all these are the integers which are greater than 3.6, right? Among these integers 4, 5, 6, which is that least integer? Which is that least integer? So you may tell among 4, 5, 6, which is least? Least means which is a lesser number. You will tell 4 is a least among 4, 5, 6. Which is not lesser than 3.6, which is not lesser than means what? Which is greater than 3.6. That's mean. That is the meaning, right? They are just giving the definition to confuse you. Which is not lesser than means which is greater than 3.6. Got it? We already listed 4, 5, 6 as a integers which are greater than 3.6. Otherwise, we might have wrote integers which are lesser than 3.6 means we will be writing 3, 2, 1, etc. Right? But here we were trying to find integers which are greater than 3.6. So we listed 4, 5, 6. Among this, the least integer which is not lesser means which are greater than 4, 5, 6 are greater than 3.6. But among this, 4 is the least integer which is satisfying both the condition. It is not lesser than 3.6 and it is greater than 3.6. So 4 is considered as a ceiling. The ceiling function will be giving you such an integer which is the least integer and which is not lesser than 3.6. So here this function will be giving you, suppose for example, if you are taking ceiling of 3.6, the answer will be 4. So the function ceiling is used to find the least integer which is not lesser than a particular real number. Suppose x is a real number, then we have to give the definition of ceiling as it is the least integer which is not lesser than 3.6. Now the other one, so we will see one more function which is known as the floor function. So in order to understand floor, it is like we have to find, as I told, nearing to 3.6, we may either approximate it to 4 or we will approximate to 3, right? But you know 3 is lesser than 3.6 and 4 is greater than 3.6. Somebody is so here after writing 3, I'll write one more definition that is related to the function called flow. Integers, first we have to write, in order to understand the definition, so it is nothing but floor means it is the integer which is lesser than 3.6, that's it. But in the definition they have given in such a way that it will confuse you. First you have to find all the integers which are lesser than 3.6. So you know 3 is less than 3.6, right? So you have to list down 3, then 2, then 1. All these are the integers which are lesser than 3.6. Now, the next step is find the greatest integer among this which is greatest. Okay, 3, 2, 1 are the integers which are lesser than 3.6. You know that 3 is the greatest among 3, 2, 1, right? So the greatest integer which is which is lesser than 3.6. Among 3 to 1, which is the greatest? 3 is the greatest. So the floor function will be returning the number for a particular real number x. The floor is considered as an integer which is the integer which is lesser than 3.6, while it is the greatest integer. So that is the greatest integer which is not greater than 3.6. So the definition of floor will be a floor, you can give it as greatest integer that is not greater than a real number x, while for the ceiling the definition will be the least integer which is not lesser than a real number x. So the definition will confuse you, but you can directly write what is the floor of 3.6. Floor of 3.6 will be 3, and ceiling of 3.6 will be 4. The term meaning floor and ceiling of a room, you know, right? So just if you are rounding off to a higher integer, then it is the ceiling. Ceiling is at the top, right? And if you are rounding off to a smaller integer value, then it will be the floor. Floor is always down, right? So it will be the least integer. So this way, this function will be giving you the integer part of a real number. This is only an example. So you can give any number and show the example, and you can write this as a mathematical function. Okay, so this definition I'll give you. This negative number, no, I'm not showing you because you will get confused. The floor and the ceiling of a real number, which is negative also we can have, but I'm not, it is just the reverse of what we saw for the positive numbers. So I'm not teaching you now, because for floor function and the ceiling function you can write, they may be asking only as a mathematical function. So I'm not taking that. It is just the opposite of what we saw for the positive numbers. Again, it will confuse you, so that's why. So the floor function, suppose x is a real number. In our example, what was a real number? Mamta, what was a real number in that example which I showed just now? Real number, any real number example you give. Mamta.
3.6, ma'am.
Yes, 3.6 is a real number. So what does floor function does? Without, if you understood, you tell me what is the, what will floor function give you? No need of this definition and all. As I told, if you consider a room, floor will be down and ceiling will be up, right? So with that, that rounding off will be happening like that. If you are taking a real number x, then floor will be giving you the integer which is lesser than that real number, right? Floor is always down, so you can take it in that way. So 3.6, the floor value will be 3, and for 3.6, the ceiling value will be what? 4. Okay, so with the definition you may get confused because it is given in a twisted manner, like not greater than, but it is, you know, not greater means it is lesser than. So I don't know, this is the definition which they have given in your textbook as well as in internet. So it is nothing but floor of x denotes the greatest integer that is not greater than x. Got it? Floor is greatest integer that is not greater than x, means it is lesser than x. So for 3.6, the integer which is not greater than means which is lesser than 3.6 is 3, right? You know, 3, 2, 1 all are lesser than 3.6, but among that the greatest integer will be 3. Understood? So if you have any confusion, you can ask. So floor of 2.6 will be 2, 3.6 will be 3, like that any number you can take. Minus value I'm not showing now because it is just the opposite, because you know, tell me, Harsha, can you tell me -2 or -3, which is greater?
-2.
-2, right? So that's why this difference is coming. So I don't want to confuse you. So you study only for the positive numbers. So again, when you write when we see the definition and write for this floor, those who are able to understand, you can just try out. I have the slide, but I don't want to confuse you. Already the definition is given in the twisted manner, no? That's it. So floor of -2.1, suppose I am giving a real number which is negative, then it will be -3. So it will be like for -2.1, the integers which are close to it. Higher level it will be -2, and lower level it will be -3. So you have to take it in the other way. So minus 2 is so now which is greater when we compare with the minus 2 and minus 2.1, which will be greater? Which will be greater, minus 2 or minus 2.1?
Minus 2.
Minus 2. So minus 2 will be greater. Likewise, so in the when you consider the floor and the ceiling function also, the function definition wise, if you see, you can just try out, those who want to try. Otherwise, I don't want to confuse you. So the notation also you can just write. If you want to write this example for negative, you can just write, otherwise leave it. Notation of the floor is simple. It is like a square bracket you have written, right? Without top. Floor means for a room, the floor will be down, right? So you can just write the square bracket without top. That will be the notation for floor. Otherwise, you can write it as floor function with the real number value in bracket. So here X denotes the real number. Got it? Now for the ceiling function, again the definition is if X is a real number, then ceiling of X denotes the least integer that is not lesser than X. So maybe in order to make it rhyming, they have made it as not less than. Not less than means it will be greater than, right? So first you have to find all the integers of that real number which is not less than X, right? Which is not less than that real number. So first write that, and among that find the least integer that will give you the ceiling. If you don't want to go by the definition, just remember that for a room, floor will be down and ceiling will be up, right? So when you take a real number, if you want to find the floor of a value, get the lower integer, and if you want to find the ceiling of a number, get the higher integer, which is greater than that real number. That's it. So for 2.6, it is ceiling. Ceiling means up. So the integer which is greater than 2.6 is 3. Okay, that's it. So for negative also I have given, and then the ceiling, floor and ceiling together I have given because I was copying the slide. So here ceiling, what is that? What is the notation for ceiling? Here listen. What is the notation for ceiling? For ceiling, the square bracket is upward. That is, you need to remove the down part for the ceiling. So this is the notation for ceiling. Notation for ceiling is the square bracket with the lower part removed. For ceiling, there should be upper part, right? So ceiling notation is given like this. Otherwise, you can just give ceiling as a function and the real number in bracket. Now, there is a relation between the floor and the ceiling. Suppose here in all the definition I told about floor and ceiling of a real number. What are real number? Which are having decimal part. Now, suppose we are finding the floor and ceiling of a integer itself. Integer means we don't have any decimal part. Then suppose we are finding the floor ceiling of an integer, then what will happen? You know that the ceiling of a number 3, it will be, you will not get any number which is not less than 3 and which is the least integer. So it will be 3 itself, right? Again, if you try to find the ceiling of 3 of an integer, that will be the same number. That means if X is an integer and if you try to find the floor and ceiling, it will be the same as that number itself. Got it? If you find floor of 3, it will be equal to the ceiling of 3, that is nothing but 3 itself. Got it? Now, one more relationship is there between the floor and ceiling of a real number. Just now I told floor and ceiling of an integer. That means floor of a integer is equal to the ceiling of an integer. Now, suppose if you are finding the floor of a real number, floor of a real number, and then if you add 1 to that, you will get the ceiling of the real number. Understood? So here in this example, which I had shown here, sorry. Now for 3.6, we were telling what was, so here you know that 4 is the ceiling and 3 is the 3 is the floor, right? So 4 is the ceiling and 3 is the floor. So what is the relation between the floor and ceiling of 3.6? What is the relation between floor and ceiling of 3.6? Tell me. Can anyone tell me if floor is 3, ceiling is 4? So what is the relation between floor and ceiling of 3.6? Floor of the
Integer.
both are integer. Floor and ceiling, it will be integer itself, right? What is the relationship between floor of a number and the ceiling of that same number? If you add 1 to the floor,
1.
you will be getting the ceiling of that number. Suppose you are taking 2.6. 2.6, the floor of 2.6 will be 2 and the ceiling of
3.
2.6 will be 3. So what is the relation? Floor of the number plus 1 will be giving you the ceiling of that integer, ceiling of that number. So the floor of it has to be considered for the real number. Okay, floor of the number plus 1 will give you the ceiling of that number. Floor of 3.6 is 3. 3 plus 1 will give you 4. That's it. So that is the relationship between the floor and the ceiling function. So in order to make it some points for that mathematical function of floor and ceiling, you can write these two lines also. So if you're finding the floor and ceiling of a real number, they are related as floor of the real number plus 1 will be giving you the ceiling of that number. Okay, so now we are moving on to the next mathematical function. This is very easy, integer value and absolute value. So these are the functions which are used to find integer value of a number, which is integer means what? It will not have the fractional part, and absolute value is what? If you want to remove the, if you don't want to consider the sign part, then you will find the absolute value. So just now we saw the ceiling and the floor function. It is just almost the same itself, but here now we are finding the just like we are not finding the least and the highest integer and all, we are just removing the integer or the fractional part when we are using the integer function. If x is a real number, the integer value of x is written as int of x and converts x into an integer. If it is a real number, you will just delete the fractional part. We will not consider the highest integer which is not higher than, or least integer which is not lesser than and all. And so here we will just consider, we will just remove the fraction part. So what will be the integer of integer function will be finding the integer part, right? So if you're passing the a real number 3.14, it will just cancel the fraction part and return it as 3. So 3.14 will be returning as 3. And if you are finding the integer function of integer part of minus 8.5, it will be returning minus 8. So 0.5 will be removed, or the fraction part will be removed. Now, so this is a small function which you can also write. In case you have lesser mark, you can write integer function. I told no, this question is asked only for, I'm explaining only for the sake of mathematical functions. One question I used to see. So this is also a function. Now the next function is absolute value. Absolute value, you might have studied in lower classes. It will be, by the definition, it tells that you will consider the distance of a number on the number line from 0 without considering the direction. You know where is negative values written on the left side of 0, positive values are written on the right side of the 0. So if you are not considering the direction, if you are not considering this left and right, if you are just taking the number as such, 6 means you are not taking it as minus 6 or positive 6. If you are just considering the distance from 0, that number gives you the absolute value. So it is nothing but in our terms, if you are just telling, if you are ignoring the minus sign, if you're not considering the sign part, that is known as the absolute value. So absolute value is indicated by two lines on either sides of the number. So you will be just ignoring the sign and then it will be returning. So either you can use the ABS function with a signed number which is passed in bracket, or you can just use a double line. Then if you're finding the absolute value of a real number, a real number will be having the fraction part as well as it is having a minus sign. So when you find the absolute value, it will be returning only the positive part, that is you will just ignore the minus sign and it will return 3.33. So you have to understand one thing in this. If you are finding the integer using integer function, if you are finding the integer value, you will not remove the minus sign Listen here, you will not remove. So integer function will not remove the minus n. It will remove only the fractional part or the decimal part. Got it? But if you are using the absolute function, it will be removing only the minus part and it will not remove this fractional part. Got it? That's why I gave this example. Absolute value will remove only the sign part, while integer function it will be removing only the fractional part. Okay, that is a small function, and those two also, in case you are not able to recollect congruence and all, no, you can write that. But always try to write the functions which I had given in the beginning, that arithmetic modulus and all, no, and congruence, all those. Now the next symbol or the function which is used is summation. Mostly this is not written as a function. It is used. These are the terms which are which we will be using to write an algorithm. Okay. So in order to reduce the length of an algorithm, we will be making use of the summation symbol, which is also read as sigma. You might have seen or you might have studied in classes, max classes, summation symbol. The symbol is read as sigma. So this is used to show the sum of a series of numbers. So I'll show you one example. Here is consider a series of numbers. Now we'll be, when we are writing an algorithm, we will not use numbers, but instead we will be using some variables, right? Suppose I am using A1, A2, A3 are the variables. Then to find there is some A1, A2, A3, or these are the variable names, right? So instead of that, you can write 1, 2, 3 also, right? A1 may be equal to 1, A2 is 2, and A3 is 3. But for writing an algorithm, we will never use numbers directly, because we can use the same algorithm for adding up a number of inputs, right? So you will not be writing an algorithm specifically for a particular problem to be solved, right? Only with the different inputs it should be working, right? So we will be writing an algorithm using a variable name. Most of the algorithms which I had taught you in last semester also, you will be using variable names, right? So when we are writing with a variable name, suppose I want to show that A1, A2, A3 is a sequence, and if I want to find this, and what I will do, A1 plus A2 plus etc. Suppose I want to find the sum of n numbers. It will be like A1 plus A2 plus etc. and then plus an. I'll just show it as this will indicate that it is a series. I'm finding the sum of the series from A1 to an. Now, in order to show in the algorithm, there is a simpler way. It is shown as sigma aj. Got it? So this symbol will indicate that we are finding this is same as a1 plus a2 plus a3 plus etc. up to an. Got it? So how we will be indicating this using the sigma symbol? Here, you know that a is a variable which is used throughout this sum, and then here only difference is a1, a2. The subscripts are 1, 2, 3, etc. up to n. So we are using a dummy variable called j, and down we are giving the explanation that where j equal to 1, 2, 3, etc. up to n. I didn't write n over here. J equal to 1, 2, 3, etc. up to n. So this variable, which will be having the value ranging from 1 to n, is known as a dummy index or the dummy variable. So this summation symbol will indicate that after replacing j value with all the values, with each time the values from ranging from 1 to n, you are adding all the values. So this summation symbol or sigma is used to indicate the sum of the series like a1 plus a2 plus a3 plus etc. plus an. So you can just first write instead of sigma, how you will expand this, you can just write instead of j, you will be writing a1, and then the next one is a2. So the sigma symbol indicate that all these numbers has to be added. So it will be like a1, and then j variable will be replaced by 2, then again a3, like that, okay, up to an. So like that, any sequence, suppose I want to write the sum of the sequences of the numbers like 2 squared plus 3 squared plus 4 squared plus 5 squared, again using the summation symbol sigma and using the dummy variable j. One second. How to write that one? Now here So this is another this animation didn't come that time. This is another way of writing that summation symbol. Either you can write down where j equal to 1 to n, but mostly we will be writing it is like j variable. We will be writing as a subscript for the sigma symbol j equal to 1 to n. So this indicate that j value, instead of writing where j equal to 1 to n, you can write with the sigma symbol. If board was there, then I can sigma symbol and j value, no, you will be writing as down to this sigma symbol j equal to 1. This will be the lowest value of j, and the highest value of j will be indicated on top of the sigma symbol. And in between, no, or parallel to that, we will be writing the variable a j. This j is should be down. Yeah, I didn't write it again. That's why. So here it should be down. So j should be down. So what does it indicate? We are finding the sum of the series in which the j value will be ranging from 1 to n. So it will be like a1 plus a2 plus etc. Plus an up to an. If you want to find the sum of series like 2 square plus 3 square plus 5 square, so what should be the first thing you have to write the, it is a sum, right? So you write the summation symbol sigma, and then here also we are going to use a dummy variable called j. And so here you should first figure out what is that number which is getting like in this series, you know, what is that number which is getting incremented, right? So here, which are the numbers which are getting incremented, we will be just showing it as j. So here also, here we have a j value. For these, here it was different because a value and then the subscript was given as j, because a is same in all. Here instead of that, 2, we are finding the square of all the numbers, right? So 2 is same, but the down number, the series is changing from 2 to 3, 3 to 4, and 3 to 4 to 5. So where we will be using the dummy variable, we will be using the dummy variable as a main number in the sequence. So you are writing it as j, right? And then what is that we are going to find? We are finding the square of all the numbers. So you are writing it as j squared. J squared. Now, this j value, each time, the first time j value will be 2, then it will be 3, then it will be 4, then it will be 5. So what you are going to do? J value, initial value has to be given as a subscript for the sigma symbol. Initial value of j value will be 2. And up to what value it is going? It is going only up to 5. In the previous case, it was going up to n. That's why we gave sigma j equal to 1 to n. Here it is going only up to 5. So you will be writing it as j equal to 2 to 5. Got it? So here, if you write sigma j equal to 2 to 5, j squared, what will be the expanded form? Here it will be replacing j value with the 2. So you will be writing 2 squared plus, as it is a sigma symbol, you will be putting plus, and then for the next value, what you will do? J value, instead of 2, we will be putting 3, right? So 3 squared plus, then 4 squared plus, up to which value it should go? It should go only up to 5. So it will be like a 5 square. So this is not anything which is serious, just to understand the summation sigma symbol or the sigma. This is also, now you can, if you have any doubts, or we can try some other series writing with the summation symbol, but it's not asked as such, just to understand the symbol sigma, which is used oftenly in the algorithm. That's it. Okay. So this is the way, you will be using the summation sigma, summation symbol called sigma. Now, the next function, now we have used many times in our program, that is factorial symbol. So factorial program also we have executed. Factorial is nothing but the product of the positive integers from 1 to n. Suppose you are finding the factorial, like 3 factorial. What is 3 factorial? We know what is 3 factorial? We know. Are you there?
Yes, ma'am.
What is 3 factorial?
6, ma'am.
How to write 3 factorial? Can you expand?
3
3 into
2. 2.
So this will be the factorial function. So if you find the factorial of any number, n factorial means you'll have to go up to n. So it is shown 1 into 2 into 3 into etc. n minus 2 into n minus 1 into the last number is n. I'm just showing it as a definition, but you know, any number you take, it has to go up to that number. That's it. So n is my number means the previous number will be n minus 1. Previous to that number will be n minus 2. Suppose I'm taking 15 factorial. What will be n minus 1? Harsha, can you tell me what is? N minus 1 will be?
14.
14. So you are just multiplying up to 15, right? Then n minus 2 will be 13. Just to show as a definition, which is applicable for all numbers, we are just showing like that. Then it will be 12 like that up to 1. Got it? So this is factorial function. Now the next term is permutation. What is permutation? Permutation of a set of n elements is arranging the members of a set into a sequence or an order. So all possible combination of a particular set of elements is known as a permutation. Suppose I am taking A, B and C, three numbers A, B, C. What are the possible combinations of writing A, B, C? So you will be telling, you will be first writing A, B, C, then you will be writing A, C, B, right? Then you may change the order of A and B. So you'll be writing like a BAC, BAC, and then you will be writing as BCA. So if you take all the possible combinations, you may see that there are 6 possible ways of writing the combinations with the 3 elements A, B, C. But first you will be writing A, B, C, and then what you will be doing, then you will be changing the order of A and C. You will be writing it as ACB, then BAC, BCA. None of them are repeating, right? So all possible combinations which are possible with the 3 numbers is given by the permutation. So there is a relationship between the factorial and permutation. If you want to find the number of possible combination with the n elements, then it is given, the number of permutation possible is given by n factorial. So there are n factorial permutation for a set of n elements. So that if there are 3 elements, there will be 3 factorial number of permutations possible. 3 factorial is what? It will be 6, right? So here in this example, we have 3 elements A, B, C. So what will happen? There will how many permutations are possible? 3 factorial. So you know it is 6. So you can write down A, B, C. You have seen that you will not be able to find any other combination other than these 6. Got it? So this is factorial function and the permutation function. That's it. So all these are the mathematical functions what we are going to have just for understanding this chapter they have given. Many other functions they have given, logarithm and all. I saw only one question repeatedly asked, that's why I gave only this many. If you want, I can give a little more, no? Logarithm and other functions are also there. Now, next, moving on to the next topic, which is known as control structures. Control structures, and we have used many times in our C program. They are just showing how when we are writing an algorithm, what are the terms which we are using in an algorithm. For that sake, they are explaining it once again. So you know that when we write a program, it will be executing. The program control will be moving from first line to the second line and then to the third line. So that flow of execution of the program is known as sequence logic. Got it? As a sequence in a line. First line will be executed, then it will move to the next line, right? So we will write the algorithm also in such a way that first line will be executed, then it goes to the next line. If there is a change in order, we will tell go to step 3, right? If you want to change the order, we will be changing it with the go to statements. And then what is the other things which we were using? You know that we have said it about the control structures and decision-making statements and branching statements in the last semester. You remember all those decision-making statements and the branching statements, what they will do, they will change the order of execution, right? The program control will not be moving on to the next line. It will be jumping from one line, skipping some lines, or it may execute the some block of lines repeatedly, right? So these type of logic is known as a selection logic. All those branching and the decision making statements are coming under the selection logic. Got it? So algorithms use modules and logic for the flow of control. Algorithms use modules means like our functions what we write, and some logic for the flow of control of the program. It can be either the sequence logic or it can be the selection logic. Sequence logic means what? Program control will be moving from one line to the other. The instructions are executed in a sequential order means it is sequence logic. If the executions, if it is depending upon a particular condition, it is executing one module means it is known as selection logic, just like our if statement, right? So depending on a particular condition, if this is satisfied, we know how to write different conditions. If, else, right? Like, we have executed many programs like that, right? So depending upon a particular condition, if you want to skip some module and to execute a particular module, you may go for the selection logic. Now, in selection logic also we have different types, but single alternative, that means if condition holds, then module A will be executed. Otherwise, that is just like our simple if statement. Got it? If one condition holds, then you execute. Otherwise, you can skip that line and continue with the remaining program. Double alternative means it will have both the true part and the false part. If condition satisfy, then module A. Otherwise, that is, if the condition does not satisfy, it will go to the false part. That is double alternative. And the third one is multiple alternative. That is what we have in the else if ladder. That is module which follows the condition